This video is a part of the course Smart Home Automation Final Submission about the course project. Our project title is Microsoft Kinect and Microsoft Band-based Respiration Rate Calculation. I am Mohammad Arif and my partner in this project is Prachi Singla. In this project we used a Microsoft Kinect version 2, a Microsoft Band, a Nexus 4 smartphone, and a laptop.
Let's start the demo. We start our WPF app that is showing human skeleton. We have to press the start button, putting the Microsoft Band in the front pocket of the subject. Then the subject is asked to breathe normally toward Kinect. Our WPF app captures the accelerometer data from Microsoft Band and chest location depth information through Kinect. When we press the save button, both of the sensor data are saved into different files.
Here we can see that Kinect.txt, that file is containing all of the depth information of Kinect sensor of the skeleton joint. That means the chest depth information in meters. And in the band.txt we saved the magnitude of the accelerometer x, y, and z axis. So let's calculate the respiration rate using both of the Kinect and band sensor provided information. First we can see that here are all the graphs. In the figure 1 we can see that this is the depth information, where we can see it is really impossible to calculate any kind of oscillation using just this information. So we use the autocorrelation. Then we found figure 2. Now this is after applying autocorrelation. Now we can see that yes, we can calculate the depth information. Same things happen for figure 3. Here we can see that it is difficult to calculate the respiration rate using this acceleration, that means the magnitude of the Microsoft Band. So we use again the correlation, autocorrelation, and calculated the oscillation, and we found this scenario and we calculate the oscillation. Now we can see that for the first case the Kinect sensor is providing 11.6 the number of breathing count in our experiment, and Microsoft Band provided respiration rate is 13.1. So here we can see that there's almost 1.5 count difference in the accuracy. This is the overall architectural flow of our project. Here a Microsoft Band is connected with the Nexus 4 smartphone through Bluetooth. Then the smartphone is capturing the accelerometer from the Microsoft Band and sending data to Microsoft Windows Azure server through a PHP web service with an HTTP connection protocol. In the Windows Azure server, we installed Linux operating system Ubuntu in the virtual operating system. Then we installed MySQL, PHP, and Apache. We wrote 3 PHP web services in the Apache server. One service is called every 2 seconds by the Android device whenever it gets any new accelerometer data from Microsoft Band. That web service saves accelerometer data into MySQL database. Next web service is called by WPF app to fetch the accelerometer data with any number of seconds. Final web service is for displaying all the data in the MySQL database in the web page. We wrote a WPF app that calls the web service to capture any number of seconds accelerometer data from the Microsoft Band through Windows Azure server-based PHP web service. Then we save in a file in CSV format. We wrote a MATLAB function to calculate the shortest periodic signal using autocorrelation filter using simple formula. Thus, we can calculate the breathing rate from the Microsoft band provided respiration rate. Then we used Microsoft Kinect based depth sensor to calculate the depth information of the chest. We all know whenever we breathe, the depth of our chest gets an oscillation of increasing and decreasing. We wrote a WPF app to get connected SDK provided depth information of the mid-spinal skeleton position. We saved that depth information in CSV format. We used the same MATLAB program to calculate breathing rate through the autocorrelation filter and sequence of period calculation. Finally, we compare both of the respiration rate together.
Here we are showing the Microsoft Band and our developed Android app. We can see that while we are shaking the Microsoft Band, the X, Y, and Z axis values are changing in real time. That means while breathing, the chest pocket location band will give some oscillation values.
This is the Windows Azure Server page where we can see that there we have created one virtual machine, one cloud services, one storage, etc. And here we can see our web page that we created to display the accelerometer data. So the accelerometer data is saved such like this, like XYZ axis with colon separated, which was extracted in the WPF app site. Here it is real time and you can see it is changing every seconds and it is updating every seconds as our Android app is getting the accelerometer data from the Microsoft band and sending over the web service, and it's saved in the cloud server's MySQL database. We calculated respiration rate using the 13 subjects that we calculated respiration rate in the demo session. Among the that 13 subjects, we have 10 male and 3 female. We counted breathing rate manually of our own and then calculated the error using this equation. So our demo session dataset showed that we have overall 15% error rate for band and 20% error rate for Kinect based respiration rate calculation. We see that for male it is really highly accurate, and for female it is more a higher error rate. In our project we use several software frameworks, like we used the Eclipse IDE for Android programming, we used Microsoft Windows Azure Service, we used Microsoft Visual Studio C# for WPF application writing. We use Kinect Studio for analysis. We use the MATLAB 2014A version. We use PuTTY for SSH connection with the Microsoft Azure service. We use PHP for web services. We use MySQL for query, and we finally use FileZilla for uploading the files to the remote Microsoft Azure server.